Hello, everyone. Thank you for joining our webinar today, Building Trust in Digital Economies with Face Biometrics. My name is Steve Craig, and I am Director of Product here at Mitek. Today, we've got an exciting panel. I'm going to introduce our speakers one by one here. First, we've got Alan Goode. Alan Goode is the CEO and Chief Analyst at Goode Intelligence, a cybersecurity analysis and consulting firm that specializes in identity, authentication, and biometrics. Alan has 13 years of research experience and has been covering the biometric industry since 2011. We're also joined by Sanjay Nichani, VP of Mitek Labs. Sanjay has 25 plus years of experience in computer vision and machine learning and is co-inventor of numerous patents in the field. Prior to taking on leadership of Mitek Labs, he founded Miracona, developing 3D sensor technology for access control systems to detect intrusions, which was white-labeled by two door manufacturing companies. Prior to that, Sanjay was Director of Advanced Products at Cognex Corporation, the leading machine vision company for factory automation. There, he developed industry-leading geometric pattern finding technology called PatMax. He has advanced degrees in business from Babson and computer science from USF. We also have Cristina Cañero. Cristina is Senior Director of Research at Mitek, where she studies new technologies for document authentication and biometric validation. Prior to Mitek, Cristina was a research manager for 10 years at eCar, an identity verification company acquired by Mitek last October. She also worked for 8 years as researcher and technology transfer project manager in areas ranging from industrial machine vision to computer-assisted surgery or advanced driving assistance systems. So thank you everyone on the panel for joining us today. I'm going to go ahead and start by passing it over to Alan Goode. Alan, please take it away.
Thank you, Steve. Yes, today I'm giving my views on face biometrics and discussing some of the trends that are underpinning its increasing levels of adoption. I would first like to discuss some of the trends that we're seeing for verifying identity in digital channels. There's a fact, there is no one identity to rule them all, no one single trusted identity that we can use to prove who we really are across all services and for cross-border scenarios. Trusted digital identity schemes are fragmented, and even in regions where there are supporting standards like the European Union's eIDAS scheme and centralized government-led initiatives like Universal ID in India, there is not universal take-up or support for use in widely used digital services. So the question is, how do organizations meet AML and KYC regulation and prove identity in the fast-moving digital age where mobile has truly eaten the world? A recent report by CACI predicts that by 2019, which is next year, banking by mobile will overtake online. The rapid adoption of mobile banking is causing banks to rethink their channel strategy and is leading to branch closures on a grand scale. Mobile also demands new ways of interacting with customers. User experience and a frictionless experience is king. Business functions that previously took weeks to take place now have to take place at the speed of mobile, which is in seconds and minutes. Next slide, please. At the same time, we are seeing mega issues with our prime authentication method, the password, a technology that is decades old and was designed for green screens directly connected to a mainframe computer. It's still the #1 method of validating someone's online presence. It has also become a security nightmare. In the age of the mega breach, where personal identifiable data, including identity credentials, are being stolen almost at will. According to the 2017 Verizon Data Breach Investigations report, 80% of hacking-related breaches are the result of weak or stolen passwords. Not only are passwords insecure, they're also not relevant or convenient for mobile devices. Remembering unique long passwords for tens of online accounts and apps and entering these into a small touchscreen is extremely inconvenient. Next slide, please. So with rising levels of data breaches, the move to mobile, and a lack of digital identity commonality, organizations are increasingly turning to the power of biometrics to deliver safe, convenient customer identification and authentication. At Good Intelligence, we've been covering analysis of the biometrics industry since 2011, and have seen a remarkable explosion in adoption across all sectors, but especially for financial services and digital commerce. We forecast in a report investigating biometrics banking that by 2020, over 1 billion bank customers will be using mobile biometrics for a mixture of identity verification, authentication, and transaction authorization. Next slide. As we've been covering the market since 2011, we've noticed an evolution in the types of biometric technology used and how they're being leveraged. There's a definite trend of getting beyond simple device unlock and user authentication, with a movement away from a reliance on integrated mobile device biometric systems like Touch ID and Face ID, to other biometric systems that can offer improved spoof and liveness detection and better performance. Face has certainly started to become more prominent as a modality and starting to get increasing levels of adoption, as it offers a wider range of use cases and applications versus other biometric modalities such as fingerprint and voice. The arrival of consumer biometrics has coincided with the dramatic improvements in machine learning and artificial intelligence technology, and this is being leveraged to improve biometric performance and for improvements in anti-spoof and liveness detection. Next, please. So, emphasizing some of the statements from the previous slide, Face offers a wider range of applications and use cases than other biometric modalities. One of these applications is for digital identity and document verification, where there are increasing levels of adoption around the world. In my opinion, it solves the pressing issue of how to verify identity and quickly onboard customers to new accounts and services in a seamless and secure manner. So thank you for your time. I hope you found my presentation useful. I would now like to hand over to Sanjay from Mitek Systems.
Good morning, everybody. Face recognition is slightly different from other object classification tasks in computer vision, just because of really the remarkable distinctiveness of the human faces. Taking numerous face images of large amounts of people to obtain all the classes is quite impractical. Also, the intrapersonal variations, that is the variations within the same subject, could be larger than interpersonal differences. That's due to maybe pose differences, illumination differences, or expression, age, occlusions. So there's a large amount of variations within the same class. Typical approaches in face recognition involve detecting faces first, and then normalizing them, extracting features, and measuring similarity of features, a process that's called matching in computer vision. I wanted to highlight 4 technical streams that has led to face recognition becoming very popular and coming into the mainstream. The first set of approaches were called holistic approaches, and these ones are really lower dimensional representations that allow linear transformation from what the faces look like from one situation to another situation. And they fail to address really uncontrolled facial changes like change in expressions and so on. Then the second stream was in the 2000s. There came approaches that use locally handcrafted, locally invariant features, which actually allowed higher dimensional representations, but that still suffered from not being able to be distinct enough, and they were also very cumbersome. They were not general enough to be applied very in a variety of situations. Starting in 2010, you started seeing a lot of approaches that were learning-based approaches, and these approaches tended to learn features, but they were still very shallow representations. They were not sophisticated enough to really sort of capture the nonlinear facial appearance variations that happen from one situation to another situation. Starting in 2012, just driven by the popularity of graphical processing units and then the massive amount of annotated data that's available, and just the advancements in neural networks, deep learning has just taken the computer vision community by storm. These deep face recognition methods leverage these deep neural networks to learn more distinctive and discriminative representations. They significantly improve the state of the art. They actually surpass the human performance, which is 97.53%, and we are close to 99% on some known data sets. All we have to do is we show the deep neural networks positive and negative examples of image pairs using huge amount of data. And the neural network automatically learns features, and they serve to compare faces that are invariant to illumination, pose, aging, and all the other things that I talked about that are the intrapersonal changes that happen. In addition, there are very novel architectures that can represent really these high-level transformations that occur from one situation to another situation. That really, these architectures allow you to discriminate and generalize at the same time. So the emphasis is really shifted from feature engineering that was happening earlier to architecture engineering, and that's because of the advent of deep neural networks. The next slide, please. So the proofing solutions, as Alan mentioned, to prove who you are moving from what you know to what you have and who you are. So what you have is really a government-issued ID, and every document has a photo. And what we do at Mitek is we build a number of authenticators that provide evidence of potential tampering of the photo. Some basic examples are human face presence. Believe it or not, there are a lot of forgeries that go through our system. There are Photoshop synthetic IDs with sketches, logos of companies, animals, and really making sure that a human is present in a portrait photo is a big deal. And also, this can be extended to make sure that the size is appropriate, the pose is okay, and also we can do some kind of age checks whether they fall within certain tolerances, because we sometimes see even kids' pictures coming through as a portrait photo. The next area that we have been focusing on is a celebrity photo or a blacklisted photo. This is basically comparing images against a known database of fakes. This is called a 1-to-n or a 1-to-many match, where you take the portrait photo from your ID and compare it against a database, basically. And this could be, people tend to use celebrity pictures. They tend to use pictures from specimens available publicly on the internet. This allows you to catch those type of fakers. Lastly, I want to talk a little bit about just photo integration. It's just how is the photo integrated into the ID itself could provide a clue of tampering. For example, the UK IDs have a style of photo where the photo has been laser engraved, so they're grayish in appearance and they appear to be floating on an ID. So having a knowledge that a UK photo looks like that can be a good thing, because we can use authenticators to figure if they deviate from that particular style of photo. Can you please move to the next slide? So moving from what you have to who you are, that's the second pillar of proofing. So are you the person that owns the document? And this is where the one-to-one match comes in, where you take a selfie of the person who's presenting the ID and the picture from the ID, the portrait photo from the ID, and compare them. And that matching technique, if it's robust enough, will tell you, is this the person who actually owns the ID? And we have a robust matcher that has false positives under 1%, and it's pretty fast. And this allows us to really work on the second pillar I was talking about. The big challenge over here is really aging. And this is due to the long renewal periods that are there for licenses. How do you compare a current selfie picture to a past picture from a photo ID? And so we have done a lot of tests around it. Can you please move to the next one? And here's a picture the Queen of England, and her picture at 90 years old, and a comparison all the way from 20 to 90. And you can see that as the age gets closer to her current age, the portrait photo gets closer to her current age, the matching score actually increases. There's a general trend. But in all cases, it's still above a threshold that we use for matching, which basically proves the promise of this technology of proving who you are. Though we can compare the selfie picture to the portrait photo and the ID, a big challenge is the selfie picture of a live person or not? And that is really a big area of research. And I would like to hand it over to Cristina to talk a little bit more about that particular area.
Thank you, Sanjay. Hi everybody. So I would like to speak about a little bit of what is the kind of attacks that we can see when somebody wants to replace the identity from another person. And here the selfie, we need to make sure that selfie is a real person and not an impostor trying to masquerade him or herself. This kind of attack is called a spoofing attack. And so in the next slide, we are going to see first what is the real problem here. And here we see an image, and there is two halves of this image. And what we can see is that one of the half, and I will not tell you right away which one, is fake, and one is not fake, it's a genuine image. So if you see the two halves, it may be easier to know because you can see the color and the texture is not exactly the same. So you can say maybe the left side of the image is the real one. But in practice, the problem is that you only have one image and you need to assess if the photo is real or not. So it is mandatory to check this. So in the next slide, we can see one of the most common attacks that we can find in our systems is to try directly print a photo of a person, which is very easy to get because the pictures of persons are everywhere, internet, social media, and also you can even make a photo of a person without its knowledge. So the first thing we can check to fight against this is to detect that the photo is framed. So if there is a frame around the person, this is a clue that the person is not real. Also, another attack which is very similar is using a tablet. You can also find it, so they even bother to print the photo. So they show it into a large phone or a tablet. And here you have also the same problems. The thing here, another clue here is that the photo of a person has not natural movements. So the person is not blinking or moving the face or having micro expressions. So in the next slide, what we can see is another thing a fraudster can try is to gently bend the image to try to simulate facial movement. So what we need to do to fight against this is first check that the movement it does make sense. So it is not an impossible movement of the face landmarks, like the eyes cannot separate regarding to the position of the nose and things like that. Or we can also check that some movements that we know to recognize, like blinking or smiling, so that are possible movements. However, in the next slide, we can see another kind of attack, which is, it is really not that common. It's very difficult because you need to record a video of the person you want to replace and supplantate. Frontally looking at the camera and making some movements. So Even if you are lucky enough to get this video, then you can use more clues to detect this kind of fraud. So one of the most, one of the strongest evidences of that this image is shown on a screen is that the texture of the face is not the same. The skin shows a texture. For instance, in the screen, you will get maybe a moire effect. If the image is printed, we will have printed noise. So the whole idea is that an imposter face is captured by the camera twice, while a genuine user only once. So this creates artifacts that are detectable. Another thing that you can do is check for the color for the same reason. The color of the skin has even with illumination changes, have some properties that are not always preserved by a printing and recapturing process. So, even if they have a very high quality image, another thing that you can do is to take a more active approach. So not only detecting random facial movements, but ask the user to challenge them and say, okay, please blink now. So this is much more difficult to get a video that does that, or a smile. So you need to have an interactive, an interaction with the system. So in the next slide, you can see another kind of technique that creative fraudsters can try, and is just print an image of a photo and make some holes and simulate the eyes closed, so that when they are asked for the challenge of blinking, they can blink. I have to say this is a very difficult setup to make that the eyes are shown and see the camera, the instructions through the camera and my eyes being seen. So this is not that easy. But in the next slide, you can see a more creative setup consisting of printing two versions of the eyes, closed and open. And then if you move it fast enough, you can switch between the two images. Anyway, here you have two things. One is that the transition between open eyes and closed eyes will not make sense. But also there is something that we have not used it yet, and is the 3D shape. So this image is flat. So we have no 3D information. So one attacker, what could do is, and this is now possible because of the rise of the 3D printing techniques, is to create a 3D mask. Until now, this was quite difficult because getting a 3D model from a person without its consent was very intrusive. But now the newer computer vision techniques allows us to get a plausible 3D model from a single photo of a person. It does not need to be the real 3D model because usually the systems maybe do not have the real 3D information. So but they can have a 3D model. So in the next slides, you can see that using this 3D model, you create a 3D mask that you can wear and show a 3D shape. Even you can ask for a mask with holes on your eyes to simulate blinking. But anyway, this is not enough because you can check, ask for another challenge like smiling or checking micro movements also. So there are a combination of clues that allows us to finally detect spoofing. So I let Alan to continue.
Yeah, let's go ahead and pass it over to Alan to give us a final word on this area, and then there's something that I'll be sharing as well. Alan?
Yes, hi. Yeah, so thank you. So during this webinar, we've discussed why face is the most versatile biometric modality. Face offers more than just phone unlock or mobile app authentication. It supports a wide variety of use cases. It solves real-world problems like how do I prove identity and seamlessly onboard customers through digital-only channels. The latest facial recognition services are beginning to leverage machine learning and artificial intelligence, and these are helping to improve biometric performance and to help fraudsters at bay, who are using increasingly sophisticated techniques that we've seen in an attempt to defraud organizations by fooling face recognition systems and beating simple spoof and liveness detection. So, thank you.
All right. Well, thank you, Alan, and thank you, Sanjay and Cristina, for all the great content. The last thing I'd like to show everyone on the webinar before we jump into Q&A is how this works in practice. So at Mitek, we have developed technology that our customers, typically financial institutions, payments companies, companies in the digital economy like sharing companies, etc., use our technology to build trust with their end users. So our product, Mobile Verify, which includes face comparison, which is leveraging some of these biometric technologies we've discussed today, allows an end user with just the snap of 3 pictures to prove their identity. So the demo you're about to see is an actual flow of using a driver's license, my own driver's license, combined with facial capture. So we're going to go ahead and play the video. It's very quick, so please watch the video on the right. The first step is to scan the ID card. So we're going to use Mitek's MySnap product. There's my actual California ID. Notice that we automatically captured that very quickly. Now we're going to move to the back of the document. Here we're scanning the PDF 417 barcode and capturing. And the final step is to capture the face. Now those snaps happen very quickly, and you can see within just a few moments here we have a lot of data. Now all this data came from these 3 pictures. Typically this information would not be provided to an end user, but it's used to drive workflow. Now specific to the face capture, there are a number of techniques that we've employed here. So first, while we're doing the face capture, we're looking for the presence of the face, making sure that it is aligned to the guide oval, that we're looking for sufficient brightness, that there's enough illumination on the face. We're also making sure that the face is in focus. Once we have those parameters met, we call those image quality metrics, we then move on to ask the user to do an active movement. In the scenario you just saw, it was a blink interaction. But we're not just doing that. As Cristina talked through the various spoof attacks, there are potential to fake a blink. So we're also using a passive technique to detect things like the screen being held up from a tablet, to detect textures, and we do this passively. So we're combining both an active technique, which is the blinking, with a passive technique, which is running in the background, all powered through a video stream, which can also give the end user real-time feedback to either correct the position of their face or to perform the actions. There are other methods that can be used as well. Challenge response is a common one in which we request the end user to do movements such as nod or smile. And generally, the more you request the end user to do actively, the more friction you create. So there's always a balance between the friction of the user experience with the security. So we generally recommend to our customers to think about your use case and the importance of the trust in that transaction, and then apply the appropriate amount of security, i.e. friction. So that's our product. What we're going to do next is open it up to the Q&A portion. So you should see an area in the webinar where you could submit questions. So please go ahead and do that. We've got plenty of time. I'll give a moment here for the questions to come in, and then we'll start to ask them of our panelists. Okay, the first question is, I think related to some of Alan's content. What is the impact of Face ID from Apple on this market?
Shall I take that one?
Yeah, I think that was related. You touched on that a little bit, Alan. So I'll direct it to you and Sanjay or Cristina.
I think what Face ID does is that I think we had since Touch ID first emerged on mobile devices and brought kind of biometric to the masses. I think it's been about fingerprint. It's been about kind of simple phone unlock, mobile app kind of authentication, from a consumer point of view. But I think that what Face ID has brought to the market is what else can be done with Face. And I think there's going to be a lot more different applications that will start to kind of emerge, not just based on Face ID, but based on facial recognition. And what, as the content of the webinar has showed us, is that the kind of leveraging that the neural networks and the AI and machine learning, it allows you to detect spoof attacks, and it provides a much more reliable user experience than we've perhaps seen on a lot of the kind of the device-based, the mobile-based biometric solutions today. So yeah, I think we're going to see a lot more use of facial recognition, and it has a much more wider, potential, I think, than some of the other modalities that we've been seeing so far.
Great, thank you, Alan. The next question is, how effective is face comparison across demographics? That one could probably go to Cristina or Sanjay.
Well, I can take this one if you want. Well, this highly depends on the training. It's like real persons. Humans also have the same issues with demographics, ethnicities, for example. If people is not used to see persons from a given ethnicity, then it's more difficult to them to distinguish. So with the newer techniques based on learning and deep learning, this means that your training set must not be biased for ethnicity, so you are able to learn which are the features that are more invariant to pose an illumination to everything, but also that are more characteristic for each ethnicity, and to cover all that.
Great, thanks, Cristina. Sanjay, do you have anything to add on that?
Again, I mean, a lot depends on some of the training databases, and since the databases are pretty extensive, there is a very good result across the various demographics.
Excellent. Another question, why is face biometrics more versatile than other modalities? Alan, do you want to take that one?
I think we're just kind of touching on the surface of what face can offer, and I think the problem with face pre kind of use of kind of deep face learning is that it was relatively easy to spoof. So we haven't really seen it deployed as much. But the versatility, I think, is that we can, as we've seen with identity proofing, we can do this great match. We can pick up the image of a trusted ID, and then we can then validate that against the person's face who's using their mobile phone. So you just can't do that with a fingerprint or an iris, etc., because we're not capturing, when we're creating the trusted documents, we're not capturing those modalities. And also, I think that we did some work in auto last year, where the use of facial biometrics and cameras inside a cabin of a car, you can also look at emotions. You can look at kind of whether the driver is attentive, which I think is very important in the autonomous vehicle market. So it offers a lot of, we use the face to not just verify identity, but to gauge how that person's feeling and how that person is. But with facial biometrics.
Great, thanks, Alan. Another question, this seems more like a product question, so I can answer it. Is the graphical user interface for the face capture customizable? And it also said Face ID. So the Face ID piece of it is Apple. Apple has a process that's quite seamless, doesn't really have the user matching a face to any oval or guide images. The Mitek product, which has a face silhouette as well as feedback, is fully customizable. So the guide image could be an oval, the guide image could be different colors to match branding. We allow complete customization of both the face capture as well as the document capture, because it's really important for our customers when they're integrating in the capture steps for those to match the brand identity. So yes, fully customizable. All right, next question. Does makeup or accessories impact results for the face comparison? Maybe Sanjay or Cristina, if you want to speak to that one.
Sure. So yeah, we have done extensive tests on these. So our database collections have occlusions, things we have had people live testing done with people with wigs, occlusion, makeup, and we have a fairly extensive collection. And yes, the match scores actually drop when you go when you start putting on more things on your face. But in general, we have seen that it's above a matching threshold, and that was the point of the whole exercise with even with aging. We've done similar tests with occlusions, and we've seen that though the match score drops, it's still above thresholds. So we have a fairly extensive and a difficult database that we test against. In that particular database, our false negatives were, as I mentioned, the false positives were around 1%, but our false negatives were around 10% or so. But still, it was a very difficult database that we have tested against.
Great, thanks, Sanjay. Looks like there's another product question. Does the face biometrics work as a standalone product? So for Mitek, the face matching is combined with our mobile verify. So as Sanjay mentioned earlier, we combine the what you have with who you are. So we're looking at the identity document as part of the what you have. We make sure that the document is authentic, that it's valid, that it hasn't been tampered with, and then we can extract the face, and then we use that face combined with the selfie and the liveness check to be able to do that comparison for the what you are. So we combine those two pieces for the identity proofing step.
Steve, I would like to answer a couple of questions over here that are there.
Sure.
One of them is, when checking the face, does it matter if you use the crop photo from the ID doc or the high-res photo that can be read from the chip inside the ID doc? So again, we can compare against both the photo from the ID doc and the high-res photo. Typically our scenario is, because we deal with driver's license and IDs, and especially a lot in the US, so we are sort of pretty good at getting portrait photos from the ID and comparing against it. So we do both. And I think there was another question around how much of the processing can be done locally on the phone, whereas how much happens at the back end. And a lot of the processing that happens right now is in the back end. And the question is, what's the latency and the user experience? I believe the whole mobile verify transaction happens under 5 seconds, I believe, and or around that time frame. And the face matching itself is about under a second. There is work that's being done to move more processing on device, and just part of our work that's going on in R&D. But yeah, a lot of the work happens in the back end.
Great, thanks, Sanjay. Looking for a few additional questions here. Yeah, I see several questions that would be best taken offline. Let me just review the last few that came in. All right, well, it looks like we've exhausted all of the questions that would be appropriate for the webinar setting. There are a few questions that we would be happy to answer directly in a chat. So we do invite you to please reach out to Mitek. We're happy to arrange meetings and calls with you personally to walk through products and answer some of the questions more in depth. We do appreciate the time that you've spent with us today on the webinar. I want to thank Alan, Sanjay, and Cristina for their time and presenting, and I hope that everyone on the line today has a great day. Thank you.
Thank you.
Thank you.